mana?
My name is Ahmad Sufika Hanif.
My name is Muhammad Insan Hanif.
We will show you
Our project is able to
Transform wastewater become clean water.
that can solve a problem in our region.
Let's get started. Okay. Every living creature needs water. Human, animal, and plants all needs water. Their population keep increase time by time. But in the other side, the source and quality of the water is keep continuing decreasing. One of the reason of the decrease of water quality is because of the pollution carried out by irresponsible industry. If this problem keep continue, one day there will be a water crisis in this world. In Indonesia, there are one of industry that often produce the water pollutant. That is a textile industry. In Indonesia, 40% of textile industry is product in Jawa Tengah, and the central of it is in Semarang, our city. Which means that Semarang is one of the biggest textile supplier in Indonesia. However, the waste from the textile industry is very dangerous because it is poisonous and very dangerous, such as textile dyes and waxes. Then, the problem comes not from big industry. Usually, big industry already have an adequate waste treatment, so it won't contaminate the water. The problem comes from small industry such as UMKM. Most of that industry don't have enough money or enough fund to make or buy an adequate waste treatment. And also they don't have enough space to add it. So from all that problem, we came up with an idea to solve that problem.
This technology is able to process high contaminant wastewater into clean water in a continuous manner. The process we have developed is an integrated process of the ozonation and membrane process. The process flow of the equipment system in more detail is as follows.
So, because we're gonna doing some experiment, we're gonna change our outfit. 3, 2, 1. Based on the problem that we have previously described, we took an initiative to create a technology that have a concept of environment. Friendly, inexpensive, high efficiency, and conscious. Wastewater enter the ozone for ozonation. After ozonation, the water will go membrane by pumping it. After the water reaches the membrane, the contamination in wastewater will be rejected.
This membrane used in this experiment is a novel material consists of polysulfone polymer and titanium dioxide. Titanium dioxide in membrane can degrade organic compound attached in membrane. Thereby, the membrane can be applied for a longer time without falling. As shown in this figure, the clean water passed through membrane barrier and collected. The remaining water, we call it retorted, is recycled to the feed tank to be reprocessed.
After that, we will discuss about the result of our experiment. Before that, let's change our outfit first. The performance of our membrane filtration process can be evaluated by two parameters, that are the permeate or the clean water flux, and the other is the pollutant rejection efficiencies. The first is the clean water flux, or how much clean water that we can obtain from this method. So this, we have a graphic based on our experiment in lab using our product Ozone. As we see in the graphic, the permeate or the clean water flux is quite stable when the flux rate is depend on the pressure that is given, which means that the higher pressure we give it, the higher clean water we can obtain it. And next is about pollutant rejection efficiency. In this experiment, the pollutant of the wastewater is focused on four major parameters, which is chemical oxygen method or COD, total dissolved solid or TDS, dyes, and ammonia. So, in this graphic, we will compare two things, the blue and the orange diagram. The blue one represents the rejection rate of conventional membrane process, and the orange one is represent the rejection rate of our product Ozone lab version based on our experiment. We can see in the graphic that the difference between the two processes is quite significant. Look at the rejection rate of the COD of our Ozone product. For the example, it is able to reject the COD up to 95% and more of it. This experiment shows outstanding result when overall contaminant rejection were significantly enchanted by Ozone.
To meet the simplicity, the proposed equipment is integrated with closed system, where the log data can be accessed from mobile phone or laptop. So the system control and monitoring can perform it anytime and anywhere.
Membrane technology to treat textile wastewater into clean water has been successfully developed. The design process system is proven to be able to solve the problem of membrane fouling. The Ozone device, based on the result of laboratory trial, was able to increase the efficiency of removing contaminant from 74% to 95%.
This proposed technology provides compact, simple, lightweight, mild operation condition, low cost, and integrated, with a cloud storage system so that it can be accessed anytime and anywhere. So that all our explanation
About our idea that can solve the problem in our city.
Hope you enjoy the video and
Thank you.
terima kasih.
Matur nuwun.
And